Distance in the plane. Today I am learning about distance formula so that I can calculate the distance between 2 points when given a graph or two ordered pairs. I will know that I have it when I score an 80% or above on my check for understanding. Distance between 2 points is the same as asking for the length of a line segment. So whenever you hear distance, think length. So to find the length of a vertical or horizontal line segment, simply count the number of units from one point to the other point. So let's look at example 1. Find the distance between the 2 points. We have a point here and we have a point here. So I'm simply going to count from one point to the other. Starting here, that's 1 unit, 2 units, 3 units. So the distance equals 3, or the length of the line segment is 3 units. Okay, let's look at example 2. Find the distance between the 2 points. So here is a point and here is a point. So, So let's go, Lord. So let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the distance is 10, or the length of the line segment is 10 units. Now, the Pythagorean theorem can be used to find the length of a diagonal line. So previously we found the length of vertical and horizontal lines. Now we're looking at diagonal lines where it's not possible to just simply count. So when you're thinking of using the Pythagorean theorem, we know Pythagorean theorem applies to right triangles. So you can think of the diagonal line as the hypotenuse of the right triangle. And let's remember that Pythagorean theorem is a squared plus b squared equals c squared. So for example 3, we're going to find the length of the diagonal line using the Pythagorean theorem. So here we have a diagonal line, and we already know that the diagonal line is the hypotenuse. So I can go ahead and label this C. Now I just need A and B, which are the legs of the right triangle. So I'll just go ahead and create a right triangle from each point. So now we've already learned how to find the length of a vertical line. So we're just going to simply count 1, 2, 3, 4. And the length of this horizontal line is 1, 2, 3, 4, 5, 6. Okay? So let's just go ahead and substitute those values into Pythagorean theorem. So 4 squared plus 6 squared equals c squared. Remember, we're trying to find c. We don't know it, so we're just going to keep that variable. 4 squared is 16, and 6 squared is 36. 16 plus 36 equals 52. Now remember, we're still solving for c, so that means we need to get rid of this square. The inverse operation of a square is a square root, so we will take the square root of both sides, making that c. And then you can go ahead and type the square root of 52 into your calculator in order to simplify it. So when we type square root of 52 in our calculator, we get 2 square root 13. So the distance is 2 square root 13. Now that is considered the exact answer. If you want to find the approximate answer, you'll simply convert that to a decimal, and we'll just round it to the 10th place. So when we convert that to a decimal to the 10th place, it is 7.2. So go ahead and be ready to find either the exact answer or the approximate answer. Let me try that again. Approximate answer. Okay. Now, the distance formula can be used to find the length of any line segment as long as you know the endpoints. So the distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So looking at example 4, use the distance formula to calculate the length of the line segment. The first thing that we'll need to do is label each point and find the ordered pairs. So I'll go ahead and label this point A and this point B. Now we need to figure out what is the ordered pair for each of these points. So for point A, it is 3, 5. I'll go ahead and write that here, 3, 5. And for point B, it is 4, negative 3. And I'll go ahead and write that here, 4, negative 3. Now we need to identify our x1, y1, x2, and y2. So if we're going to use, this is our first ordered pair. This is our x1 and y1. So our x1 is 3, and our y1 is 5. Our x2 is 4, and our y2 is negative 3. And now we're going to simply substitute those coordinates into the distance formula and then simplify. So we have our distance formula above, and I'm simply going to put each number in the place of the x1, y1, x2, y2. So D equals the square root of x2, which is 4, minus x1, which is 3, close parentheses, squared. And then we have y2, which is negative 3, minus y1, which is 5, squared. Okay, and now the first thing we're going to do is simplify those parentheses. So 4 minus 3 is 1. And always keep it in parentheses. And then negative 3 minus 5 is negative 8. Now let's keep going. The next thing we're going to do is square. So 1 squared is 1. And negative 8 squared is 64. And now we simply need to add. So 1 plus 64 is 65. So we are left with the square root of 65. Now go ahead and type the square root of 65 into your calculator to see if that will simplify. And it will not. So D equals the square root of 65. Remember, that is your exact answer. And then to find the approximate answer, simply convert that to a decimal. And we're rounding to the 10th place, so that will be 8.1. Example 5. Use the distance formula to calculate the length of the line segment with the endpoints 7, 2, and 6, 3. So the first thing we need to do is to go ahead and identify each thing that we need to go into the formula. So our x1, assuming this is our first ordered pair and this is our second ordered pair, our x1 is 7, our y1 is 2, x2 is 6, y2 is 3. And then let's go ahead and put that into the distance formula. I know that's not on this page anymore, so I'll write it down really quickly. Okay, so let's start with our x2 is 6 minus our x1, which is 7. Our y2 is 3 minus our y1, which is 2. Now remember, do your parentheses first. 6 minus 7 is negative 1. And 3 minus 2 is positive 1. Negative 1 squared is 1. 1 squared is 1. So 1 plus 1 is 2. We are left with the square root of 2. Square root of 2 does not simplify. If you're not sure, of course, you can always just type that into your calculator. But we are left with d equals the square root of 2. And if you want the approximate answer, convert that to a decimal, and you will get 1.4.